sometimes when solving equations, you will have a problem where the variable is not on the left-hand side, but rather on the right-hand side. I find it easiest to go ahead and flip my equation around and put the variable on the left-hand side. And you'll see later why that's very helpful. But for some of you guys, having the equation look the same way each time is going to help your brain a lot. And for some of you guys, it won't matter. So you don't have to do this. But just keep in mind that if A equals B, then B equals A, right? So it doesn't matter. If two things are equal, it doesn't matter which way we write it. So I'm going to rewrite this as 5 plus m plus negative 11, I went ahead and changed subtraction to addition, equals negative 6. So now I can continue the equation and solve. So give this one a try. Let's see how you do. You should end up with m equals 0. Now we're going to review absolute value a little bit. Remember that when you take the absolute value of any number, it becomes positive, whether the number started out positive or whether it started out negative, because we're talking about distance. So if we have the absolute value of x equals 4, then we know x could be either 4 or negative 4. So again, this number is the distance or absolute value, so it's always positive. And then the value inside the absolute value bar, that's the number on the number line. And it can be positive or negative. So the absolute value of 4 is 4, and the absolute value of negative 4 is 4. Whereas the absolute value of 4 equaling x, in this case, x could only be 4, since we're finding the absolute value of 4, and the absolute value always makes it positive. This number is always positive. This one could be positive or negative. So if we have a problem, an equation, like the absolute value of m plus 4 equals 7, we're going to start solving this equation like we normally would, using our opposite property. We'll deal with the absolute value part last. So we're going to add the opposite of 4 so that we get the absolute value of m by itself. And since we add that negative 4 to the left-hand side, we have to add it to the right-hand side as well. So we end up with the absolute value of m plus 0 equals 3, or the absolute value of m equals 3. Now we can solve this. What numbers could we place in to give us an absolute value of 3, or a distance of 3? We could end up with 3 or negative 3. So the absolute value of 3 equals 3, and the absolute value of negative 3 equals 3. Again, we can complete a check step. So the absolute value of 3 plus 4 equals 7. 3 plus 4 equals 7, that's true. Yeah, we have to check both of these. The absolute value of negative 3 plus 4 equals 7. Again, 3 plus 4 equals 7. That's true. So both of those answers work. Next, we're going to talk about equations with roots. So what is the inverse operation of a square root? Do you remember? It's a square. So if we want to undo the square root, we can just square it. So I'm going to come in and square the square root of x. And that gets rid of the square root. If we square the left side, what are we going to have to do to keep this equation balanced? We're going to have to square the right side as well. So the square root and the square cancel, and we're left with x. And x squared is 64. Again, we can check this to make sure it works. The square root of 64 does equal 8. So that is correct. Here's our original equation. The square root of 64 equals 8. Now you try the next problem, the square root of x equaling 6. You should end up with x equaling 36, because the square root of 36 does equal 6. We know this is true. So in the next problem, x squared equals 5, we would like to undo the square. So how do you undo a square? What's the inverse of squaring? Square rooting, right? So I'm going to take the square root of x squared. And if I take the square root of the left side, what do I have to do to the right side? The same thing, right? To keep the equation balanced. I always do the same thing to both sides. So I'm going to end up with the square root of x squared. They cancel each other. What does the square root of x squared equal? X, right? And what does the square root of 5 equal? Just the square root of 5. So that's our answer. So to check, we're asking ourselves, does the square root of 5 squared equal 5? sure. The square root of 5 squared equals 5 because that's the same thing as the square root of 5 times the square root of 5, which equals the square root of 25, which equals 5. Try the next problem. The last problem, you should end up with x equaling 12. When you take the square root of x squared, you get x, and when you take the square root of 144, you get 12. And you can check that. 12 squared does equal 144. So you always want to use inverse operations to get x by itself. When x is being squared, take the square root, and when x is being square rooted, square it. And let's just review real quick for all of our different operations. So today we talked about when you are working with addition, when something's being added to x, and this includes subtraction because we're going to change subtraction to addition, then you're going to work with the opposite property and add the opposite of whatever number is being added to x to both sides. So whatever number is being added to x, you always add the opposite of that to both sides. And that is really the gist of what we've learned today with our addition equations. Now when we get to multiplication equations, we will be talking about reciprocals. And today we also talked about when x is being squared, you take the square root. So when x is being squared, you take the square root. And of course you do it to both sides. And we talked about when x is being square rooted, then you square. So when x is being square rooted, then you're going to square it. That's the inverse operation of square rooting. And you square both sides to keep the equation balanced. So the whole idea is whatever inverse operation you perform to the side with x to get x by itself, you must also do the same to the other side to keep the equation balanced. It's extremely important.